Hi, here's a problem movie-goer from Polish Olympiad. There are n days, each day there is one movie, and every movie has some particular score assigned. Your task is to find a consecutive sequence of days to maximize the total score of those movies that you see exactly once during that interval of time. For example, here, if this is n, the number of days, m, the number of movies, doesn't matter much. Here's a sequence of movies being screened every day, then scores. The optimal range turns out to be this one. And during those days, there are movies 3, 2, and 4 that you watch exactly once. So for those, you get a score. Here there are scores for movie 1, 2, 3, and 4. Hence we got scores for 3, 4, and 2. We get this to the 3 plus 6 plus 6 to the answer. So the answer is 3 plus 6 plus 6, which is 15. If you want to read the full statement, you can pause the video right now. Let's quickly talk about n-square solution, which is too slow. When reading the input, it's convenient to decrease the ID of a movie, and then instead of numbering from 1 to m, we have that from 0 to m minus 1, which fits then using some array or vector. Later here, I read values, scores of every movie. Then answer is initially 0. And I want to consider every interval, but if I do that separately and every interval I consider in linear time, I would get n cubic complexity. Let's see the code, which is only n square. What do we have here? Count will be the number of times I see some movie. L is the left end of the interval of my range of days. I iterate with R, the right part. Score is 0, and as I go with R, with right part, I add every next movie, and I use this array count to know if now I see the movie for the first time or maybe for the second time. I read movie ID, the thing from the input. X is increased by 1 count of the number of times I saw this movie. If it is now 1 after increasing by 1, then I increase the score by the score of this movie, by its value. If it's 2, it was 1 a moment ago, I should decrease by 1, not by 1, by the score of this movie. And here I consider answer to be the current score. Notice that when I consider interval from, let's say, 2 to 5, then when I consider interval from 2 to 6, I don't recount all the values. I just have some current score, and then I just append one movie in constant complexity. Notice that here you don't have to clear the whole array in complexity of m, even though in this problem it's guaranteed that m doesn't exceed n, so it would be okay. But we don't need to do that. We can just iterate again through the same elements and clear those, because only those we possibly marked as non-zero. And this is it. This is n-square solution. If you want some more time to analyze this, you can pause the video and spend some more time on that. And in a moment we'll talk about faster approach. Let's analyze the sample test a bit more. If I focus on one starting point of an interval, our range of days, and write down what is total score for every range, in particular notice that it can decrease sometimes, like from this value 14, if I add one more movie, which is 4 again, I lose the value of score of movie 4, and I know that this score is 6. So from 14 I got down to 8. And if I take this whole range, the only movie that appears exactly once is 2, its value is 3, and this is why here we have the score of 3. Now what happens when I, let's say, consider intervals that start 1 day earlier? They include this extra 1. If I just take this range of 1 day with movie 1, I get score 5 for this. If I take movies 1 and 4, my score in total is 5 plus 6, 11. Then for this range, only movie 4 is counted, so it's 6 right here. Then if I add movie 2, it will be 6 plus 3, 9, and so on. If I add one more movie, 4, this cancels the previous 4, cancels the score for that. And so minus 6 again, it will be 3. and for that last movie I already saw 1, so I don't get extra score for that. It's again 3. And now try to see some similarities between this sequence of scores and this sequence of scores. Maybe it can be easily updated. The only difference between an interval starting here and lasting till some day and an interval starting 1 day later, the only difference between them can be movie number 1. For every other movie, 2, 3, 4, either in both cases we get the score for this movie or we don't. And this is why this total score till here and till here in both cases can differ by 5, or cannot differ at all if in both cases we do or we do not get this movie. Here we see 9 is plus 5 is 14. In fact, for this whole interval, 6, 9 and 3, the corresponding interval below is greater by 5. The previous number here, 11, it is 6 plus 5. So those scores, for some time we should subtract 5 from the previous sequence of scores, and for some time we should add it. When I'm looking at this movie number 1, it's very important where is the next movie of the same number, the same ID, and it is here. For every interval which starts here and contains this one, so exactly once, so it's here, 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 I get it's plus 5 to the answer. But it's cancelled when I start 1 day earlier because I already saw this movie before. So for ending my movie marathon anywhere in this interval, I should get minus 5 to the answer. On the other hand, for ending it anywhere here, I should get plus 5 to the answer compared to the previous situation. And by previous situation, I mean here starting previously here and considering going to the right. Now new situation is starting here. And this new situation get plus 5 to the score if I end anywhere here, and minus 5 if anywhere in that other interval. So it turns out it's important where is the next movie of the same ID and yet another movie of the same ID. And this should give you a suggestion about maintaining this sequence of possible scores if you finish somewhere and doing range updates on using that segment tree. We will somewhere add 5, somewhere subtract 5 and ask for the maximum in this sequence of scores. So this sequence of scores previously, if it was 6, 11, 14, 8 and 3, now it should become this thing, and we should also ask for the maximum in that sequence. Let's think about it in one more way though. Starting anywhere, you can think what a brute force would do if it went to the right. At every position, like starting here, at this position we add plus 6 to the answer because we see this movie with score 6 for the first time, then plus 5, plus 3, minus 6 and so on. Now what happens when I start 1 day earlier? Obviously now for this new movie I get plus 5 immediately right here, here still plus 6, this time minus 5 here, and the same way here plus 3, minus 6, and this one changes 0, so I will say plus 0. Because if I start all the way over here, I already saw twice movie number 1, so it doesn't matter if I see this one again as well or not. And this sequence of changes, the one a moment ago and new one, it doesn't change a lot. It can only change in constant number of places. In this occurrence of movie here, ID 1, and next 2 occurrences. Here we see from plus 5 it was changed into minus 5, and from minus 5 it was changed to 0, plus a new one appeared here. Those are the only 3 places where it can change. A new idea is go with start of interval, let's say from right to the left, and every time you consider a new beginning, update this sequence of changes, and what is a possible score, the answer, total answer, for this sequence of changes? It is some prefix, because taking interval from here to, let's say, here, it means taking changes up to this position. This is prefix sum of this sequence of changes. What we should do is maintain this sequence of changes and answer a query about the maximum prefix. This again can be done with a segment tree, and in a moment I will show you how to do it. This is a segment tree built over a sequence of length 8. For simplicity, let's assume that it's a power of 2. We need maximum prefix in the whole sequence, let's say. By the way, in this problem, initially the sequence will be filled with zeros, and we will go from right to left and slowly change some numbers, so every moment the sequence will look something like +3, -2, +7, and in this sequence we ask for maximum prefix. For example, prefix from the start till here, it will actually represent just interval like this. Max prefix in the whole sequence is either max pref in the left child of the root, or the sum in the whole left child of the root, plus max prefix in the right part. And this is a function, this is an equation that we'll use to merge two vertices into a parent. So if we, for this vertex and for this vertex, if we computed already their max prefix, and also as we see the sum of elements because we need it, we'll use this formula. For example, if the optimum in the whole sequence is this interval, we will consider it by taking sum in the left vertex, this part, plus the best prefix in the right child subtree, in its part of the sequence, and it will represent this part. If instead of this max prefix in that right part was this one, it would mean that in total, instead of taking everything till here, it's better to end here, if this prefix is better than this one. It might become more clear with implementation, so let's see it. First, this is a very convenient struct or a class for node of a segment tree. It has two values, sum of all elements below and prefix max. If it was a standard segment tree with sum in interval, we would just have here a sum. And it has a function merge, which takes two nodes, left child and right child, and it updates my values, my sum and prefix max, using those two. Usually a segment tree problem is about figuring out what values you want to store in a segment tree and what is a merge function. In this problem we don't need lazy propagation because we don't operate with ranges. I have a constant infinity equal to billion plus 5. I just want it to be bigger than n. We'll see later what it does. Reading is the same as in the previous version. I create my segment tree. For convenience, I take base power of 2 initially equal to 1, and then I multiply it by 2 as long as it is smaller than n. This way I append the sequence, I increase the sequence size to be a power of 2. I create a vector of nodes of size 2 times this base, and I have a function which takes index I and new value val, and it puts this value in leaf of a segment tree. Leaf number I has coordinates, has index base plus I. I set values as value and max of 0 and value. So here sum of all elements is just value, and prefix max is maximum of 0 and this value. And I update on the path to the root. Nothing fancy here, I just run function merge. Then answer is initially 0, at the end I will print answer, where stores occurrences of every movie. I will need 2 previous occurrences, but let's say I store all of them. In a moment I will explain this particular thing. I iterate from the right to the left, from n-1 to 0. MID is ID of this movie. Vec is for simplicity name for this vector of occurrences of this movie. Last is the last element of the vector, second last is the second last element. And now, thanks to the fact that here I put by default vector of 2 values infinity, I don't need to here make an if for empty vector, or vector of just size 1. I prefer to put here ifs instead of making ifs later here. Infinity here is very convenient. Then, if last is not infinity, then I change its value to minus something. It was, let's say, plus 5 a moment ago. Now I want to say minus 5 there, here plus 5 at my current position I, and also that second last element is now 0. It was 5 minus 5 and something to the right. I want to change this into minus 5 and 0, and myself I change to plus 5. Assuming that 5 is score, the value of now the current movie, answer is just in the root of the tree prefix maximum. And I push back my index to this vector of occurrences of this movie. At the end I print answer, and remember about longs in this problem, because the total score can exceed 10 to 9 or 2 times 10 to 9 easily, so int is not enough. This is everything, but you should try to implement this whole solution yourself, or maybe the one with updating ranges, just so you would make sure that you understand everything correctly and you practice your segment trees a little bit. I hope you enjoyed this problem and see you next time. Bye bye!